Continue recording. So this is week 2 in MSDS621. Do this a little closer. Might make it easier for people to hear me. So we're going to continue our foray into looking at different ways to get data that is not normally in a pandas format and manipulate it. Although this week it's a little different. Oops. Try that again. RMO, edit, there we go. Because we're going to work first with Excel spreadsheets, which actually are a format that pandas can read. But again, for the more for the exercise of how to manually manipulate them, we're going to do that. Because you may have instances where you want to get data out of a spreadsheet and put it into a database and do all kinds of different things with it. So we'll do that kind of for the exercise of it as much as anything else. All right. Hopefully everything works the way it's supposed to. I think I need to delete a couple of files here before we start off too much. So just delete them all. And does that. This poor computer is so slow. Okay. It's out of my way. There we go. Working with Excel files. Okay. So, let's get started. So, like I said, what could be considered a cruel trick? We'll mention that pandas can read Excel, but we're not going to do that much tonight. We've talked more than once about the fact that you should always look at your data before you get it and try to import it someplace. 95% of the time that rule kind of applies, but if you're working within a proprietary file format, you kind of need to use the corresponding application. So if you have something like a .xls file or xlsx, you kind of have to look at it in Excel format, or export it, I guess you could do it also. The library that we're going to use is called OpenPixel. I don't remember if that's installed by default or not, but if it's not, it's easy to get. So the it's optimized for working with Excel files, and it's as easy as just saying load workbook. So we do that. And now, if you think about an Excel file, the way it looks when it loads, you've got the main spreadsheet, but then down at the bottom, you've got little buttons for other sheets. And so we kind of continue that metaphor throughout this, that you open a workbook and then you can look at all the different sheets that the workbook contains. So in this case, the one that I opened really just has one sheet. In case you were wondering, AAPL is Apple's stock ticker quote, stock ticker abbreviation. So what we have here is 10 years of Apple's stock data that we're going to play with tonight. And it came to me in Excel format, so that's what we're going to mess with. When you start up looking at a spreadsheet, one of them is active, the top one is active. And so you can ask it, what is the active sheet and what's that sheet's title? Right. Then from there you can reference individual cells or columns or whatever in the active sheet. And you do need the sheet to be active in order to get to it. So if you've got multiple sheets, you've got to treat it basically just like a list and iterate through the sheets until you get to the one you want, and then you can get to the cells. And that's probably more confusing sounding than it really is. But if we take this, top sheet and look at the first cell in the first column, then you get this. It's a cell type referenced by the sheet name, which really isn't very useful. But there is a dot value attribute that we can look at, and that has the string date in it, which if we look at that data, oops, that doesn't work. Let's look at one of the individual ones. Doesn't work either. Well, I don't want to start Excel, so just take my word for it that that's the right thing. It's a row header, column headers is what it is, and date is on the far left. So that's correct. You can also access individual cells by row and column. And so that's, sheet.cell with the row and column in it. And so in this case, that's the correct value for that cell. You can also work with ranges. So on Excel, how you can, click in the upper corner and go to the lower right hand, and it gives you a box-shaped range. You can do essentially the same thing here with a slice notation. Which again, interestingly enough, this does tell you the cell that it's working with, even though it doesn't give you the value. So now, in 620, we talked about iterators and iterating and, different forms of that word. So, for our purposes here, we'll say that iterating is using a loop, a for loop. And as we saw up above, you can get, cell objects, want to get ranges. And so we're going to look at that with a loop. So in this case, sheet has this iter rows function, which does exactly what it says. It iterates rows and returns a row object to the value variable. And so if we do that, you can see what we've got. So here's that header row, and then below that, date, time, a high, low, closing, volume, et cetera, et cetera. In this iter rows, you can tell it, min row, max row, UV values only, et cetera. So it's really very convenient. Of course, there's nothing magical about this, value variable here. It's just a variable, and I just used the name value. Apparently, Merlo didn't like that exactly, so it put an underscore on it, which is fine. But that was an artifact that came from the translation from a Jupyter notebook. So I thought that was interesting. And so in this case, then value is a tuple. Each one of these is a tuple, and you can get to the stuff inside of it with list mechanics. So here you can, print an F string and use the curly braces and use numbers to get to each individual thing, like so. Okay. Any questions on that? That's the basis of what we need to know here for the assignment. There's a little more later on. Okay. And if not, let's talk a little bit about relational databases. And I realize that although some folks here have quite a bit of database experience, a lot of people don't. So let's start from the beginning and kind of talk about basics. Python itself ships with SQLite database. SQLite is a really good one to know. You see it a lot in online tutorials because it's file-based. It's a relational database, just like Oracle or MySQL or any of those. But instead of having to have a big relational database management system loaded and running, it'll do everything just with a file on your hard drive. As an interesting aside, Marimo notebooks are very tightly integrated with what's called DuckDB, which is another file-based database system. And it would probably be a good idea if you like the Marimo notebooks to learn the DuckDB thing, because it's really, really extremely convenient. One thing that you'll see over here on the side is data sources. And you can add a database just simply with hitting the plus sign and then doing any of these to define the source, one of which of course is the DuckDB. And when you do that, and then you have access to the Duck database, and you can write SQL, pure SQL in these cells, not SQL wrapped in Python the way we're going to do tonight. So it's extremely convenient. Another reason to know SQLite is it's said to be the most installed database in the world because every application needs a database of some sort. And so like your browser, your Chrome browser, uses SQLite to keep track of your history and all of your bookmarks and all of that stuff. So literally every browser in the world has a SQLite attached to it, including the ones on your phones. So it's for that reason alone, it's good to know it. So with that thought in mind, then let's move on. There's a set of steps that pretty much you always have to do when you're connecting to a database. You've got to actually do the connection, and that gives you a connection object, which is just a handle to the database, a name, basically. You can use the connection object to do queries or other functions. And when you do that, then you can save the results to a variable. The variable itself is going to be of type cursor. And as you'll see, you can also define cursors through the connection object and then tell the cursor to go do things. A cursor is essentially just a row column store of the results of a database, which is itself iterable. So for demonstration purposes here, let's create a couple of data frames from dictionaries. And we'll have these represent our employee and our department tables, more or less like we did last week, right? So employees and departments, we've got employee IDs, employee name, department IDs. Department ID is connected to the department table, which is a lookup table, et cetera, et cetera. It's all very simple. So we'll import SQLite 3. And then over here, we'll create data frames with pandas. I said we weren't going to, use pandas, but we will a little bit. Um, so we create the data frames with pandas,
Hey,
and
Mike.
yeah,
Would you be able to like close the left toolbar just so the main notebook screen is zoomed in?
you bet.
No.
You
Thank
need, do you
you.
need, you need the main notebook to be bigger, like bigger text?
That would be great.
How's that?
Yeah, that's perfect. Thank you.
Thank you. Thanks for saying that. 'Cause I can't see your screen, so I don't know what it looks
Yeah,
like. So you got to help me out. Thank you. Appreciate it.
no worries.
Um, okay, so we start up a couple of data frames, the employee data frame and the department data frame, and we get them to print out and yada yada. Great. Um, so one thing to keep in mind, it's important. If you try to create a table in a database and the table already exists, it's going to cause an error, probably a value error. Um, and so there's a couple of different ways to handle this. The accepted way generally is called exception handling, which I'll show you in a second. Um, since we're using SQLite, we need to tell SQLite where to store the database file. Um, I have a data underscore week 2 folder, and we're going to put it in there. And so let's do this. So I'm going to have this variable named con, which is my connection to SQLite. It's going in the week 2 data week 2 folder, and it's going to be called imp.db. Pandas has this toSQL function, which takes your data frame and a connection object, and then writes your data frame as a table to the uh, database. So we do that, and we don't get any real output out of it. But if we look now in data week 2, there's the file, which I don't remember if it was in the recording or not, but I deleted that file a few minutes ago. So I know that that's new, and that's what it's supposed to be. Yeah. Um, so if that file had existed, and I probably should have left it there so that you see the error. Um, if it had existed, it would have thrown an error. Errors are called exceptions. And exceptions are, of course, different from syntax errors. A syntax error means that you got something wrong with the Python language that you're using. You know, forgot a quote, or put a brace on wrong or something like that. Um, but exceptions are something external to the Python language that went wrong. As in, you tried to access a null value, you tried to put an integer into a floating point, or something like that. So when you are trying to handle exceptions, you can try to do some operations that might throw an error. And if it does throw an exception, oops, um, then you can handle it. In this case, we're just going to print it out to see what the error was. There's other things you can do um, down here to handle it. Try a different database or do some other kind of validation on your data itself or whatever, depending on the error. Um, and so here, when I do that, now there actually was an error thrown, and so it tells me that the table employees already exists. Um, so So that's a nice way to deal with errors. So now interacting with a database from Python. Once again, back in the database theory, there's two actual languages to SQL, DDL and DML. DDL stands for Data Definition Language. That's what we use to create tables, to create databases, to create schemas. So in other words, anything that can define the data and how we're storing it is DDL. DML is data modification language, which is how we access the data after it's been stored. So in the case of our employee table up above, employee and department, we were able to skip the step of creating the tables because pandas did that for us. In most cases, when you're creating things like this, you have to do that step yourself, and I'll show you that in a few minutes. By far the most common thing that you'll be doing is using the select command. Select is how we get data out of a database. And when you're doing a select, there's a specific and fairly rigid syntax to that. Pause for a second. All right. So actually, it's something in the room, so I better look up the display. All right. So, as I was saying, when you're doing the select command, there's a fairly rigid syntax that we use. It's the keyword select, and then you tell it the columns that you're trying to get, and then from, and then you tell it the table that you want the columns from, and then where acts as a filter. So it gets, the specific data that we want based on what's in the where command. You'll also see a lot of times people write these keywords, SQL keywords in all caps, because, SQL came out, way back in the dark ages before lowercase letters were invented. And so it's just kind of become convention to do those in uppercase. But, I'm an old Unix C programmer, and for me, caps make my skin crawl. It's like, fingernails on a chalkboard. So I will probably forget to do that more or less on purpose. Just know that if you see it in a book, if you see it online, those words are going to be capitalized. You don't have to capitalize them. So a lot of times when we're writing this stuff, you can break it up to make it look better. So we're going to select column A, column B, column C from some table where some column equals a value, one of the columns. It could be column B, it could be column C, whatever. And so that's the filtration there. And usually the SQL is ended with a semicolon. Right. So an example from our employee table might be that we want to select employee ID and employee name from employees where the department ID equals 1. And if we do that, then that gives us this kind of return, employee ID 1 at 4, employee names Tom and Tim. Okay. So that's the quick and dirty theory about what we're doing, right? One of the first things that we might want to do when we connect to a new database is ask about its schema or the tables that it's holding. And so for SQLite, there's this SQLite master that keeps track of all of the tables that it knows about. And all database systems have some sort of master tables. They might be called something different. You may have to figure out, some sort of naming convention. For example, Oracle puts a $$ in front of all the system tables. And so you need to know that. But here, so let's go ahead and do that call and execute. And then we can do, remember I told you that a cursor is what gets returned from a query. So I named the cursor because it's easy to remember. In the case of SQLite, it actually doesn't do the query until you tell it to. And one of the ways to tell it is to fetch the results. And so you could fetch, certain results, or you could do a fetch all. For our purposes, fetch all works just fine. So that's what I usually do. In this case, the result that it gives us is a list of lists, which you can see by the, open and close braces here. And so it's telling us that our database has table names of employees and departments. Let's see. If you wanted to count the number of tables, here's the number of tables that are in this database. You could do it a different way too. There's a couple of different ways to do it. But this is fairly reliable. And so, as you can see, what I'm doing is asking the SQLite master table to return the name of the column, contents for every row whose type has the word table in it. In other words, that master table has lists of column names, it has lists of table names, all kinds of different things. And so I'm looking specifically at the column that has the word table in it, as opposed to, something else. And so it's kind of a confusing way to say what I'm doing, but it's also the most technically accurate too. And of course, you could look at that SQLite master table if you wanted to and see what all is in it. It's not terribly interesting unless you're a CS nerd like me. Let's see. So if we look at the type of that cursor object, it tells us it's a cursor object. All right. So let's see, we had cursor actually came from up here and we did a fetch all. And so now if we come down here and we look at it again and do fetch all and look at output, it's empty. So what's going on there? Anybody want to hazard a guess? Well, there is actually a close method for cursors, and I didn't call that. It shouldn't automatically close. But what happens is, if you're familiar with Python generators, the cursor is a generator, and when you iterate through the cursor, it essentially consumes it and empties it out. Yeah, and so that's what's happened here. The fetch all up above emptied out all the contents of that cursor, and if we wanted those contents again, we would have to re-query the database, which is a little bit weird to do with Merimo. I was trying to do that earlier, rerun that, and I wasn't getting exactly what I thought I would get. If I re-execute that and then come down here. Yeah, see, it didn't give me anything. And so that's something really weird with the way that Merimo is doing the live, updating and keeping track of things. I'm not exactly sure what to do about that yet. Why it does that like that. Your best bet is if you need those results, just give it a different name so it knows to do the query again, I guess. So anyway, looking back up here, we found out that we have two tables, employees and departments, which is
I think you wrote cursor one, but you ran cursor.
right. So yeah, yeah. I didn't want to do this fetch all or this fetch all. I wanted to go straight from this. Yeah, okay. So anyway, tables in our database, employees and departments, which is what we expect from our pandas data frames that we had up above. So another way that you could do this is you could use the count function. Count does exactly what it says it's going to do. It counts the number of things that are put into it. So in this case, if we say select count star, what it will do is count all of the results that come back from the where clause. Right. And you can put things other than a star in there. I'll tell you what the star means in a minute if you don't know. But star is what you see most often. It basically means count everything. You could also tell it to count like the first column or something like that. But for us, the distinction is really minor and it kind of doesn't matter. So now if I do that, I can get it to give me the two directly. And notice here on the fetch all, I actually used the double braces, double brackets to get at the number that I wanted, right? Because like up here where we had it, I wanted, here, so there's, the zero row and the zero object in the zero row, right? And so that's what gets returned here. I just, didn't show that. But that's what's going on is you've got row and column in that cursor. And so I have to access it with, row column index it. All right, questions so far? Hopefully this isn't too far outside of anybody's experience. Okay, so you can get a list of the column names from the master table, like I said. But then you wouldn't necessarily know what table that they live in, unless you write your query such that it tells you the table that it comes from. But it's actually better just to write, query a table and ask the table directly what is in it. And in SQLite, the cursor's description property will give us column names of the table that it was run on. So here, if I say select everything from employees, that's what the star is. In this case, it means everything. It's a wildcard. Select everything from employees, then ask for the description. It tells me there's an index and an employee ID and an employee name. Then there's department ID also. So interestingly enough, you can see the employee ID was linked. So it only tells you one employee ID, both tables have it. All right. If you just want a list of the column names for say the employee table, then you could use a for loop, you could use a list comprehension, you could use a map with the lambda function. Did you close the door? And so here's all three of them. And you can choose which you like better. So a regular for loop. Right. So in this case, we're iterating through that cursor, and the first iteration will give us rows. So it iterates by row first and then by column. And so that's why we only need one set of square brackets here, because each one of these things that comes out into the call element is going to be a row. And so we want the zero element, as you can see here. A list comprehension is essentially the same thing. It's just a squashed down for loop. And so that gives us the same basic thing. And here you could use a map, which, if you remember, a map, its purpose in life is to apply a function to a container. In this case, cursor one dot description is the container. And we're going to say apply, give me the x0 for each x that comes into the lambda function in this case. As I've said before, the big trick on lambdas and all these things is remembering what your container is so that you know what each item in the container will be. So when we do this lambda, our container is, these lists up here, right? And which essentially is a row. And so then each item that it pulls off that description is going to be a row, and we wanted the first column in each row. So that's how that works. Like so. Questions? No? Okay. So some basic statements. As I said, the asterisk is a wildcard character. Means give me everything. And so the most basic query that you could do is say select everything from a table. And there's no where clause. That's optional because it's a filter. If you don't want to do any filtering, you don't need to put a where. So in this case, I can say select everything from employees. And it gives me everything from employees. Notice there's no headers though. I could also get it to do a join. And so in this case, I'm going to get employee name. So I give it the table first and then the column from the table. You can also give it a short name like that D right there, but you have to tell it in the from what that D means. So I want the employee name from the employees table. I want the department name from the department's table. I'm going to join those two together. And that means it's a left inner join by convention. If you just see the word join, then it's left inner join. And we'll join on the employee's department ID being equal to the department's department ID. So every place those two are equal, it will give us a result. And get a cursor out of that. And when we iterate that cursor, then we get that result. Formatting could be better, but that's what it looks like. All right. So now we could use a trick like that to get a search for all employees whose name starts with T. The percent sign is another kind of wildcard. In this case, it means, what's that? Right, yeah, it means we're matching a partial in this case. We want it, everything that starts with T, but anything that's back behind it. And so when we do that, it gives us Tom and Tim. Okay. Any questions? Anything at all? I wouldn't expect there to be. I will warn you guys, when I originally wrote this FTE, the book that I was using, I keep referencing at the beginning, it used this library called Dataset that essentially made database connections look like dictionaries. And it's a really, really convenient way to deal with databases. Unfortunately, when I looked at it today, that library hadn't been updated in a couple of years. So I figured it's probably a dead project, and I spent all afternoon very frantically writing it out of this FTE. And so if you see something in here that references this thing called dataset and you don't understand what it's saying, that's what it's saying. All right, moving on. So another very common operation is you'll want to be able to insert data. The syntax for that is insert into some table name, and then in parentheses, the list of columns you're going to insert, the keyword values, and then in parentheses, the list of values you want to insert, where the columns match, the value matches the column. So the first value here goes into the first column, the second value goes into the second column. The columns don't have to be listed the same way that they are in the table in the database, but you do have to match up the value in the column, right? So column 1 could actually be, over here, but then value 1 would have to be over here. Okay. Hopefully that makes sense. It should, be kind of intuitive, I hope. All right. So if we were to actually do that in our Python, let's insert this new employee whose name is Jeff Davis. He's going to have an employee ID of 6 and a department ID of 1. And in this case, Pandas inserted that index number on its own. We didn't have to do it. Similarly, in databases, most of the time, when you have something like an ID column that you're trying to make into a primary key, you don't actually insert that value either. You'll let the database auto number it for you, and put some constraints on it so that there's no repetitions, there's no nulls and things like that. And you'll see a little bit of that in a couple minutes. But in most cases, you don't have to, do something like insert this index or this employee ID. Pure SQL, the insert would look like this as we have it. In Python, you can do, give it just the, straight string to insert, and when we do that, sometimes you'll get a return off of something like this. Some databases will tell you how many items were inserted or something like that. In this case, it doesn't. SQLite doesn't do that. And it returned a cursor to us, but it was empty. And why are you not going away? Okay. That's going to make it really hard to navigate from. But anyway, if we do a select all from employees, you can see on the bottom there's our Jeff Davis, just the way we inserted it. Okay. I have got to try to get rid of that. There, that'll do it. Okay, so usually if you try to insert the same data more than once, a really well-designed database will give you some sort of an error telling you that you inserted it again. The reason that it does this is because you want each row in a table to be unique in some way. That's part of the reason that we use the database's auto numbering for the employee ID. Because we know that it will always give us a unique number for that field. Right? If you have duplicated data to that level, then you'll get an error on the insert telling you that, probably give you an error on a unique constraint, unique item constraint violated or something like that. Now, another common thing to do is to do a delete. And notice here that we have a delete from some table and then a where condition. I will tell you right now, the where is important. If you forget the where clause, it will delete everything in the table. I know this because I've done it. And it is very hard to explain to your boss what you just did to the client's table and why we have to spend the rest of the day fixing it. So remember to put the where clause on there. Let's see. So here, for example, if we wanted to delete that Jeff Davis guy, we can delete from employees where employee ID equals 6. And if we do that and say select all from employees, then he is gone. And I have that in the middle of my screen again. Yay. All right, so let's put Jeff back in, Jeff Davis. And there he is. So we did another insert. And we use the same values because there's no reason not to. So the final thing that you might want to do fairly commonly is an update. So in other words, you have a row existing in the table already, and you need to change one of the values associated with it. And so it's kind of a mix of the update of the select and the insert. We tell it first off that we want to update some table, and then set is an actual word that you have to use. So update table name set some column equal to a value, another column equal to another value. And you can have as many in there as you want or need. And then again, there is a where condition. Again, don't forget the where, because otherwise it'll do it to everything in the data in the table. So for example, we might want to update a table called state abbreviations and set the abbreviation column equal to CO, where it used to be equal to COLO. That was the old way of doing state names for addresses, and mailing was a 4-letter address. One person may be old enough to remember that. All right. And so if you only want to update one row, then you need something unique about that row. Again, that's a reason to have, your primary key and have it not null and have it, unique, and etc. So for example, here, I can update the employees table and set department ID equals 2, where the employee ID equals 6. So we're changing Jeff Davis, we're moving them to a different department. Is what that amounts to. And so you can see Jeff moved from 1 to 2 or something like that. And then finally, it's good form to close your database connection when you're done with it. In the worst case, you could lose data from a buffer not being flushed or something. It certainly uses some amount of memory and handles and things like that to keep them open. So you do a connection.close. Okay, that's the quick and dirty on databases, right? That will get you like 70% of everything you ever need to do with a database. If you just remember that and do it well, everything else you can look up and figure out as you go. Joins are a little bit hard, I will admit. It took me a long time to get the hang of joins. But other than that, any questions on any of that? No? All right.
Yes, MS1 functions, I use repeated. Don't do interaction.
Yeah, don't do that. Yeah.
Done as to test the break condition properly, as to the break name. Without something articulated or algorithm.
And in case you can't hear those of you online or in the recording, Ravi's telling a story about making database changes in production and how bad it is, and learning how to do these kinds of commands that way. So all right, we're gonna move on now. We're gonna work with Excel files. and the relational database. So use case one. Let's say, for example, that every week or something, your manager receives some spreadsheet data that he wants to save for further analysis. You know, a little bit of Python code, and you can take it directly out of the Excel sheet and put it directly into a database very easily, right? As a matter of fact, you know, I always tell my students that I will always help you, you know, even after you graduate, if you've got questions, you can ask. And one of my students that graduated did about 6 months after he graduated, he came back and he had exactly this situation. He hadn't taken this class, but he needed to be able to read out of a spreadsheet and, you know, go into a database. And so I was able to send him this particular lesson, and it helped him out. But, you know, these kinds of things happen in real life. So what we're going to do here is we'll use the Open Pixel, and we'll take one of the Excel files out of our file list. So in here in this AEPL data, I've got, you know, 10 or so Excel sheets with a year's worth of stock ticker data in there. We'll take the 2009 file and work with that as our example, or, you know, our case study. For the rest of the assignment, you guys get to work with everything else, all the other data. We'll use Python. What's the combination? Yeah, I'll show you. So it's not a big stretch of the imagination to, you know, do like a cut and paste and, you know, take 10 years worth of data and, you know, do an insert. But the point is not, can you do it with 10 files? The point is, can you do it for 100 files or 1,000, you know, files, something like that. And so with something like that, we want to be able to do it programmatically, right? So if we look at this, whoever saved this stuff was really very nice to us. All of the file names followed the same format, with the year being the very first part of the file name, and then underscore AEPL data XOSX. So in all of these files, the only thing that changes is that year number right there. Also, that year number is consecutive. So it should be obvious to you what we're going to do. We'll have you know, a for loop essentially with a counter on it, and then the result of that counter will get stuck on the first part of the file name, and you can iterate through the files in the directory that way, right? So to start that off, we have this variable called input name, which is that static part of the file name. And we have our database file, stockprices.db. And I got to remember to run those, right? So now if we create our connection, SQLite will create the file for us. I hope. Let's make sure. It should be here. Well, it should have done it. It may actually be lazy and not do it until we actually use it. I hope that's what's going on. Okay, but it shows up over here in the data sources. So that's a good sign. You know, so at this point, you know, the database should be completely empty. We haven't done anything with it. We will have to create the table that it needs. And so if, as you saw, if your database already has the table in it and you try to recreate it, you'll get an exception. So I've got a couple of real simple little functions here that will get all the names of the tables in the database and then delete them. This is because the SQLite database doesn't seem to have a drop command. Most larger database systems will have a command that allows you to drop a table. And I wasn't able to find that for SQLite. So this is our quick and easy replacement for that. So if we run that, then if I say delete all tables and I pass in the connection object, it should do nothing because there's nothing in there. But it's not a bad check since I know I wanted it to be empty. Anyway. So let's open that 2009 data file and get the header row and figure out what's in there. So I'm going to construct the data file name with the year here and the input name from up above. Okay. This should be a big hint for you in how to do this in your homework. Okay. We use the load workbook command and set the first active workbook like so. Now, the first row, which in Excel, the rows are start from 1, not from 0, like every other civilized thing does. So if I want the first row, I actually use a 1 right there. And I want the first column, and that tells me that the word date is in that first cell. So that tells me that I got the first row, and it also tells me I can access it, and it tells me how to access the cells. All right. So, this little 2 lines of code right here is a big sanity check to make sure that what I'm doing is correct and I understand what I'm doing. Right. Okay, so just about ready to create the first table. And I've got to do this by hand, manually. And in order to do that, the DDL for creating a table, I'll skip down a little bit here. The DDL for creating a table is create table with the table name, the column name, and the data type of the column. So in order to programmatically create our table, we need to know the name of each column, which is that header row, and we need to know the type of data that's going to go in that column. That's a little more problematic. There may be a way to ask the Excel cells what they're storing, but as an exercise in figuring it out, I figured it out. So I got a couple of helper functions, one of which is called isFloat, and it takes some cell value. Part of the reason that I'm doing this is because when we read it out of Excel, it comes to us as a string. So even if it looks like a floating point number, it comes to us as a string, and we've got to figure out that it's floating point or character, with a period in it or something like that. And so that's part of the reason for doing this kind of the hard way. So let's see, isDigit will return true if the string is an integer, and it gives false if there's a decimal point. The float function throws a value error if there's letters in the string. And of course, our dates always have a slash in them, right? So I can use these facts to figure out the string that I'm given, what kind of thing it is. And from there, I can return whatever I need. SQLite, the data types for the columns are integer, real, date, and text. Other databases have different words for that same type of thing. So you'll need to figure out for your database what you've got. For example, a real common one here instead of text is varchar, which means variable character length. Another real common one is instead of real, it'll be just number, or something like that. So, you need to know that. All right, so there's my functions that'll tell me what I have coming from the database. And I test it out and I get what I expect. Right? So now that should be about everything I need in order to create a table. So if I take a real row out of the database, out of the spreadsheet, excuse me, and I stick it, through my functions, it tells me that that first one is a date, and all the rest of them are real because they've got decimal points. So everything seems to work. You might want to put those functions away someplace and, be able to use them if you need them. So as I said, our SQL DDL, create table, table named, and, data type and all that. All right, so I need the header values, the header, words, in a list, not, a long string. So I'm going to break it up with a little for loop. And we'll do that like that. And the first row of cells is our column names. It's our header row. So we do everything from row 2 on, which is, of course, made a little bit more complicated by the fact that something like enumerate usually starts with the number 0. So, you can adjust that, or here I just did math to subtract 2, so it does it that way. But I've got the number of header objects, header strings. And here is the start of my create table DDL. Notice how I have an ID here. And I'm telling you it's an integer primary key and to auto increment it. So that's what you do with, primary keys fairly often. Then I'm just going to iterate through a row and add in that header name and the type that I'm getting from my little functions up here. And as you'll notice up here, someplace, this is essentially a tuple, right, with commas in between each one. But if you have a comma on the end before the parentheses, you'll get an error. So I have to detect if I'm at the end or not. If I'm not at the end, then put a comma there. If I am at the end, just skip on down, and then I'll put the closing parentheses on it. So in action, what it looks like is that. So we created a table, AAPL, with an integer primary key, a date, closing, volume, open, high and low are all real values, floating point values. Okay. So that's just the string. Now we've got to actually send it to the database and make it create the table for us. And we do that with a cursor. So we take the connection object, we create a cursor object, we tell the cursor object to execute our string, and then we tell the database to do a commit. That's very important. The commit is what tells the database to actually write the value. Before the commit, it's essentially temporary at that point. You can look at the table, but it's the table in memory, not the table on disk. And the commit is important. I spent like 30 minutes this afternoon trying to figure out why my database didn't have anything in it until I remembered I had to do a commit. And the reason for that is most civilized databases do an auto commit for you, but apparently SQLite doesn't. So it's very important. So we go ahead and execute that. And that should create our table. Okay. So now from there, we can do our inserts. And this is where it gets really fun. So SQL allows for variables in the insert strings, and that can be represented by question marks. So what we're going to do is programmatically build the insert statements with question marks where the values would go, and then give a list of values at the end to be substituted back in. So that's what this looks like. So we've got our, our columns from the header values, and we start our insert string, kind of like we did before. I'm going to iterate through the header values, and take each one of those as the column name in the insert part. So it's literally going to take the column name out of the header, put it into that part of the insert statement, and then come over and figure out the value that goes in there too. And then finally, when it's done, it puts that string on the end. So it closes our column names, and then says variable values. Okay. And then down here, it goes through a for loop and figures out all those values. And it does all that, and each time through the loop, it does an insert. As it exits the loop, it does the commit. Okay. So it was running because there's errors. Oh, food. You don't like the call right there because I've got it someplace else. Let's do that. Because I got the wrong value there. There. Okay, now it did the insert for us. Okay, now as a final check, we can look at the number of rows in that database file, and then look at the number of rows in the database and compare them to see if they're the same. So in the worksheet, there's 83 rows plus the header, and in our database, there's 82 rows. So they're equal. In other words, it did all the insert for us the way we wanted. Okay, so that's how to take something out of a Excel worksheet and stick it into a SQL database. There's our close, the way I said we should do. Now, what if you want to go the opposite direction? You've got a database and your boss wants to see the data in an Excel spreadsheet. So we can do the same type of thing. There's a little function that will print rows, like from a worksheet or something like that. So that's a little helper that we can use. Okay, so let's create a new worksheet and add a header and some data, just so that you can see how it gets done. Okay, so we've got our workbook, a new workbook object. we say that there's an active sheet named sheet 2, and then we have rows. And as you would kind of expect, it's a list of lists, right, with the first one being the headers. So when we do that, we tell it just to iterate through this rows variable and do appends onto the worksheet. And when we do that, this is what we get out of it. So now, at this point, it should be fairly obvious what we need to do. And you open the database connection. You query the database to get the collection of the data that you want. It'll be in a cursor. Convert that database data into a list of lists. You create a new workbook and worksheet. Get the column names as for the header, and then you append the header and the rows to the worksheet and save the worksheet as an Excel file. That's kind of pseudocode for what to do. So here's the database connection. And I wanted to check and make sure, what the table name was in my database. It happens to be Apple, AAPL. Good. Right. And so now, how many rows do we have in there? We've got 82 rows. Okay, that's good. So we know there's data in there. If we select star, then we get lists of lists. Right? And so that means that we can use, nested list syntax to get at the individual pieces of data. We'll select everything from the table, just because at this point, that's what I want. But you could use a where clause on there and filter it down to only certain things. So that's the data from the database. So now for example, let's look at all of the days where the stock closed above 30. So here, my where clause is where close is greater than 30. And you can see there's 3 days. That should give you everything you need in order to write a worksheet as an Excel file to disk. So create a new workbook, have an active sheet. There's our database cursor, select everything from Apple, get the headers, and append the rows that we got from up here, like so. And then you do a workbook.save and give it a file name. And so there's the file right there. Sorry, didn't do that. But that 621 demo, as you can see, is what I just wrote. So that is pretty much everything you need in order to do the homework. What is the homework, you might ask me? Well, The homework is to translate a spreadsheet into a database. And I've got some text in here, don't repeat yourself, so I want things in functions, and et cetera. Basically, the idea is to take all of these data files and stick them in your database. So we load all of the data files into the SQLite database. You'll have slightly more than 2,500 rows in it. If you have a number significantly different from that, then you probably inserted stuff twice. So query your final table and show that you have fully loaded all the data. Row count is pretty much good enough for that. Then after you know that you've got the right data in your database, answer some questions. So find all the days where the stock closed lower than 25. Tell me how many days there were. Print the first 5 rows. Find all the days in year 2017 where the stock closed above 150. And then create a new Excel workbook with every query on a new worksheet and save it to disk. Okay. Questions?
So save the output of each query as a new sheet.
Yep.
Okay, cool.
Yeah. So back here where may not be here, but back here where you're seeing new sheet, you'll have to get a new sheet for each one of these and append it onto the workbook.
Okay, that sounds good.
This is how it works. And of course, you can always look at the results in Excel and make sure there's, the little tabs at the bottom with the names on it that you've given it and all that kind of stuff to check and see if it's correct. Questions? Okay. Let's see. One bit of business. I said last week, I don't remember if it was on the recording or not. So I'll say it again here. If you look at the assignments, there are end dates and times. In other words, it will not accept homework turned in after that date and time. Okay. I am tired of people doing things like turning in all 8 weeks of the homework on the last weekend. And I feel like I got taken advantage of. So we're not doing it anymore. Turn it on time or don't turn it in at all. So that's it. That's all I've got for you tonight. Any last questions? All right, we're done.
Okay, thanks, Mike.
Yeah,
You bet.
thanks.